Hi, I'm Ada Watkins. I'm a biology major and currently a junior. During my fall and spring semester of my sophomore year, I was a Chem 101 LA, and I really enjoyed my experience and would love to LA again for Chem 430 or 433. I loved helping the students in a field that I was passionate about, and I loved meeting students and forming a friendship with them. I remember I would see students around campus and we would say hi to each other. So it was nice that I could have an impact both in the classroom as a teacher and outside the classroom as a peer that someone could rely on. I remember when I was taking chem classes, I used the ULAs so much. I would sit on the end of the rows, like intentionally, so I could talk to the ULAs easier. And for my orgos, I would go to the ULA sessions once a week, and it was super helpful, and it showed in my performance and my understanding of the topic. So I would love to give back to a system that has done so much for me as a ULA. I know that I would be a good ULA because I've been, on the opposite end of things. I've been a student who was kind of frustrated over a topic or a problem that I didn't understand and would go to the ULAs for help. So I know how to give positive feedback and give motivation to students because that's what I was looking for when I was going to my ULAs for help. So I'm gonna show my ULA skills now with a problem from Biochem. So the problem is draw a Zwitter ion for arginine and indicate what its isoelectric point is. So first, what I like to do is just kind of make sure I completely understand what the question is asking and define any terms that I may not know or some terms that aren't very obvious. So first is a Zwitter ion. So a Zwitter ion is going to be an amino acid that has a net charge of 0. So this is going to be in its like fully neutral state where all the charges balance out. And then arginine, it's an amino acid that was one that we had to memorize, so I'll draw it shortly. And then isoelectric point, this is given as a pH value when something is at its Zwitter ionic state. So its isoelectric point is going to be at a pH when the charge is 0. So these are our kind of three, I would say, keywords to take away from this problem. So first, drawing arginine. I'm gonna draw it in its fully protonated form because I feel like that'll help us set us up for success in the problem. So first what I'm drawing is the R group, and then this is our amino group, and then our carboxyl group. Hopefully you can see that pretty well. All right, next I am going to show what places would be protonated or deprotonated, and those are the places that we're going to be looking for on our amino acid. So first on our R group we have this H is going to be deprotonated at a pH of 12. Arginine is a strong base, so this is why it has such a high pH for this to be deprotonated. And then for our amino group, this was something that we had to memorize. This is going to be deprotonated at a pH of 9. And then our carboxylic acid group is going to be deprotonated at a pH of 2. These pHs are always going to be the same for any amino acid. The carboxyl group will deprotonate at a pH of 2, and the amino group will deprotonate at a pH of 9. So going back to the problem, draw the Zwitter ion form for arginine. So like I said before, Zwitter ion charge of 0. So we know that we have a neutral here, we know that we have a positive here and a positive here. So if we want to have it at the Zwitter ion form, we're going to start at the group that's going to have the lowest pH. So if we raise our environment to a pH of 3, this would deprotonate and have a negative charge. So now this is a negative. So now there's a net charge of plus because we have negative, positive, positive. And now if we raise it to a pH of 9, our amino group will deprotonate. So this will now be neutral. And this will change from NH3 plus to just NH2. So now we have our Zwitter ion form, negative, neutral, positive. That's going to make a overall neutral charge of 0. Okay, so that takes care of our first question. And the next part of the question is, what's its isoelectric point? So our isoelectric point is we're going to take the two pHs. We're kind of like surrounding the neutral charge. So when we have a neutral charge, we had to reach a pH of 9 to deprotonate the amino group. So pH of 9, and then the next pH is the pH of 12. So once we already passed this 2, we don't use it, we just use the next two pHs. So pH of 9 and then the pH of 12 of our strong base. And to find the isoelectric point, we're just going to take the average. So it's kind of the average between our two pHs where we would find the neutral charge of arginine. So 9 plus 12 divided by 2, we're going to get, hopefully you can still see this, an isoelectric point of 10.5. Yep, and that is how we would solve that problem. Again, I'm Ada Watkins, and I'm applying for biochem, either 430 or 433. Thank you.